Okay, so this is another video just getting you ready for the topic test on similar triangles, congruent triangles and statistics, and a big shout out to all the people whose names start with the letter C and maybe sit next to a person with the letter C. That might be good, and sit across the road from someone whose letter might be S. Okay, so looking across. Okay, so we're going to do a congruent proof to start with, so look up your rules if you need to, but when you're ready, come back live. Okay, so in the congruent proof, you've got SSS, SAS, AAS, RHS. So if you want to, just play by the eliminations. We don't have three sides given, so we can cross that out. We don't have a right angle. We've only got one angle, so we're really stuck with SAS to prove. And this is how we're going to do it. Okay, so angle B equals angle F. And why is it the same? Because they gave it to you in the diagram, so that's a given. So, and also I've got first line is introduce the triangles. So for the first line for triangle ABC and triangle DEF, then we do angle B equals angle F, given. So there's a 5-line proof. Next one is this one stroke is the same as this one stroke. So AB equals EF, and why? Because it was given. Next, number 4, double stroke equals double stroke. So BC equals DF. Why? Because it was given. And here comes the last line. And step 5. Now this is where you've got to be careful. So triangle A, B, C. You can do any letters for those ones. So A to B is up to 1 stroke, and then B to C is down to 2. So we need to go from the 1 to the 2. So we've got to go that way, okay, because we went that way, A, B, C. So we're going to have triangle. So congruent to triangle, you can use the word congruent if you want to, E, F, D. Okay, so the letter order doesn't matter for the first one, but it has to match the second one. So you could do any letter for the first one. And the reason was SAS. So the proof has to have 5 lines, introduce, and then the next 3 lines are to do with the 3 letters of your proof, and then the last line is just the conclusion with the reason. Okay, so that's our proof's done. Okay, moving across. Okay, so now we're going to prove that triangles are similar. So again, it's a 5-step proof. Again, I'll just remind you, similar triangles. We've got AAA, we've got triple S, we've got SAS, and we've got double AS. Oh, not double AS, we've got, what one have I? RHS. Okay. So they're different. AAA is all angles the same, sides in the same ratio, 2 sides in the same ratio with the internal angle the same, and the right angle, hypotenuse and sides are in the same ratio. Okay, so have a go, work out which you've got, but the clue is, like, whenever you have parallel lines, you've got angles. So I'll give you a clue, it's going to be the AAA. So can you have a go, and when you're ready, come back live. Okay, so hopefully you've had a think about it. So for triangles A, B, C and triangle CDE. Okay, so angle A equals angle E, and the reason is alternate angles. And you say alternate angles are equal, so the reason is. Okay, and then we've got heaps of other ones, but let's just do this one here. Okay, so angle ACB equals ECD, and the reason is vertically opposite angles are equal. And the fourth one is, well, angle B has to equal angle D. And there's 2 reasons. Once you've got 2 A's, then you must have 3 A's. Or the other reason is alternate angles are equal. Okay, So we've done it and finish it off with line 5. Now, not so important with letter order, so A, B, C, so A, B, C, so we're going to go, this side is going to match with this side, so we're going to go E, D, C. And the reason was AAA. Okay, now I've already given you a clue, like angle X, so that angle there was the same as that angle there, so double and the vertically opposite, double and the vertically opposite are the same, corresponding, and then what you have to do is work out the ratio, so 8/2 is the scale factor. Okay, so 2 is being multiplied by 4 to get 8, so 3 is being multiplied by 4 to get x, so x equals 12. And we have to do y as well. So 3 is multiplied by x, so y is multiplied by 4. Sorry, I'm running out of space. Y is multiplied by 4 to get 7, so y equals 7 on 4. So once you work out the scale factor, that's the scale factor for all the sides. The scale factor could have been 2/8 if you're looking from the small to the big, from the big to the small. It just depends which way you want to. I always like to have whole numbers, but just read the question in terms of which way they want you to scale. Okay, moving across. Okay, here's another similar. Prove that triangles are similar and find x. So in this particular one, sometimes you can't see the triangles, so I suggest you redraw them. Okay, just doesn't have to be to scale. So we've got A, E, C, and we've got B, D, C, and we've got a right angle and a right angle, and a 4 and a 5 and a 3, and we've got nothing there, so we don't have to worry about that. 12 and x. Okay. So have a go now at the proof. Again, you've only got the 4 proofs you can use, and see how you go. Okay, so we're looking at how to prove them. We don't have all the sides, so we can't use triple S. So what we need to do is see if we've got a triple A question again. Okay. So angle C. Okay, first line is introduce the triangles. So for triangles A, E, C, and triangle B, D, C, first line. Okay, angle C is common. It's in both triangles, so that's your first A. Number 3, angle E equals angle D. Why? Because it was given to you. And that means that that angle at A must be B. And the reason is, once you've got 2 angles the same, then the third angle's the same. Okay, so that's your proof. Once you've got 2 A's, then you've got 3 A's. So 5, finishing off with the proof. So triangle A, E, C is similar to triangle. So we're going A, E, C, so we're going down, so we're going B, D, C. Okay, and is that all we have to do? Nope, we've got to find x. So x matches up with the 3 as corresponding, and the ratio, scale factor, will be 5 and 12. Okay, so 12 over 5 equals the scale factor. Okay, so 5 is being multiplied to get up to 12, so 3 is being multiplied to get up to x, and so x is 36 on 5, or 7 1/5, or 7.2. Okay, so just keep looking how you're multiplying from the top to the bottom, or the bottom to the top. Okay, so hopefully you've got a good idea on that one, and let's move across. Okay, so we're looking at some statistics. These won't be quick ones, like we're going to do mean, median, mode, range, and describe the skewness. Okay, so we've got a dot plot and a stem and leaf. So when you're ready, come back and we'll see how we've gone. Okay, so the mean is the average. So we've got to add up these numbers. So we've got, it's long, if you want to do it longhand. So you've got 5 plus 2 6s are 12, plus 4 sevens are 28, plus 3 fours are 24, plus 9. So the sum this is. So 17, 45, 49, 69, 78. So the average is 78, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 7 and 1/11th is the mean. Median, 11 numbers, so we've got this middle of one number, it will be the 6th score, 1, 2, 3, 4, 5, 6. So that the median that is, will be a 7. The mode, the most popular score, the 7 is the highest column. The range is the highest score, which is 9, minus the lowest score, which is 5. And describe the skewness, it's pretty symmetrical. So it's a symmetrical data. Okay, let's have a look at the next one. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 numbers this time, so this will be a bit easier. Okay, so change the colours. Okay, that didn't change my colour at all. Okay, so this time we've got some bigger numbers. So we've got, again, you've got the calculator, so you've got 5 plus 7 plus 9 plus 10 plus 3 15s are 45 plus 21 plus 28 plus 34, and then divide that by 10. So I haven't got my calculator with me, so I'm going to do this longhand. 12, 21, 31, 76, 77, 77, 97, 105, 125, 129, 159, I think. So the mean is 15.9. Oh yeah, I've got my page extender. I can do that. So I didn't think I had my page extender. That's that one done. Median. Now, because we've got an even number of scores, there's going to be 2 middles. It'll be the 5th and the 6th. So 1, 2, 3, 4, 5, 6. So they're both a score of 15. The mode is the score that occurs the most, and that's 15 again. The range, highest minus the lowest. So the highest score is 34. The lowest score is a 5. So that's 29. Now this time, the data is bulked at the top and then spreads this way. So it's pushed to the lower end, which I would love to call negative, but that is positively skewed. Okay. I think we've got one more page to go. Let's have a look. Okay, so people were surveyed about the following, ranking their TV shows from 1st to 5th, or best to worst. What colour is their favourite colour, how tall they are, and what size shirt they wear. And each of those is an example of numerical or categorical. So can you please have a go and see what you got? It's hopefully you can look up your notes if you need to, and pause, and when you're ready, come back live. Okay, so we'll do the numbers first. So we'll do 3 and 4 because they're easy to do. Now, how tall you are is a measurement, and measurements are continuous. So that is numerical continuous. And what size shirt is a number, like size 12, 14, 16. So that's numerical. And they only come in certain numbers, so that's numerical discrete. Okay, so now we're left. Okay, so we've done those two. So nominal or ordinal. So ordinal, it gives you a clue there's an order. And that would be 1st to 5th. So that's nominal with order. And colours don't have any rank, so that's nominal. And what's the one I left out? Sorry, categorical nominal. Okay, and that's the end of the video. So hopefully you've got a good idea of some of the questions. It won't be everything, but that gives you a better clue. Okay, thanks, bye.